In his latest article, John Ozer demystifies encoding and transcoding, clearly explaining the difference between the two. Wait, what? Why should anyone read an article defining encoding and transcoding? Doesn't everybody already know that?
The thing about these terms is they're not defined in any dictionary. And while they sound pretty close, and most people think they know what they mean, there are subtle differences. And we thought it would be useful to have, the differences outlined so people understood, what type of product they were trying to buy, what a product that they read about on the web actually does. I mean, for example, there's a big difference between a live encoder and a live transcoder. So just defining those terms would make it easier for people to understand, what type of product they're looking for and what type of products they're looking at.
In the article, you talk about 3 conversion operations. What are they and what are they called?
In the article, we talked about something topical right now. We talked about basketball, and we talked about 3 conversion operations that would occur associated with the basketball game. So you've got the camera set up, you've got a video mixer, and then you use a live encoder to send the video into the cloud. And then once it's in the cloud, it's going to get transcoded into multiple streams to distribute via AVR delivery. So you've got the live encode, and then you've got the transcode in the cloud where you're taking in the live stream and then creating the encoding ladder. At the same time, somebody sitting on the side might be taking a feed from the live output, storing that to disk, cutting out clips in Adobe Premiere or some other product, and then encoding those clips, and then uploading those to, Twitter or some other social media operation. So you've got your live encode at the point of origination. You've got transcode in the cloud where you're taking one stream in, outputting an encoding ladder, and then you've got a traditional video on demand encode when you're creating the clips to upload to social media.
So transcoding applies to live streaming situations when the time is of essence. This would be typical high volume transcoding applications where hardware transcoding is recommended. Can you explain why it is much more beneficial to transcode with hardware?
So it's much more beneficial to encode hardware for a couple of reasons. Number one, you're going to get more density out of a single server. So instead of getting 1 or 2 streams out of a server using CPU-based operation, you're going to get full encoding ladders out using ASIC-based transcoding. That not only is going to save you CapEx, it's going to save you power on the way out. You also get much more predictability when it comes to load. We know exactly how many streams our ASICs can transcode at any given point, for consistently over a long production type. With CPUs, that varies. So typically, you can only run it between 60 and 80% of the CPU if you're encoding with software. But with ASIC-based transcoders, you can typically run it 95 to 100% and not worry about spikes that could stop the show.
So we can transcode with GPU or ASIC. How do I decide which one is better for specific application?
Whenever you look at a hardware transcoder, you look at 4 things. You look at cost per stream, and I think ASICs are going to be lower. You look at power usage, and ASICs are definitely going to be lower there. You want to look at density, or the amount of streams you can get out of a single device. ASICs will be better there. And then you want to look at quality, and our quality is going to be pretty much the same or a little bit better than what you would get from the typical GPU.
It seems like ASIC-based transcoding is truly a way to go, and it is available. But let's say I'm already heavily invested into CPU, GPU-based infrastructure. How can I implement ASIC-based transcoding and still utilize what I already have?
So if you've got a CPU-based system, you've got some pretty hefty servers, you should be able to drop in ASIC-based transcoders, whether it's T408s or Quadros, and you'll get much greater throughput, much lower power consumption, and you should be able to recoup your costs in a matter of months due to power savings. If you've got GPUs, obviously it's going to take longer to recoup your investment. But if you drop in our cards, you can control them with FFmpeg, GStreamer, or an SDK. So it should be relatively simple to port over to our solution. And again, you'll get higher throughput, lower power consumption, and equal or better quality.